Kia ora koutou. Welcome, and I'm welcoming you here from New Zealand. It's nighttime here, but we're very thankful for people taking their time to attend this webinar series today. So welcome to the third session of this webinar series collaboration between the YESS community and the High Weather Project. This webinar series is entitled Exploring the Role of Citizen Science in Weather, Climate, and Related Projects. The webinars, which have started in September and will continue running towards the end of the year, aim to enable discussion on the topic of citizen science and bringing together scientists, stakeholders, early career researchers to foster an understanding of resilience to high impact weather. Today, we have a really exciting topic on crowdsourced hazard maps. Can the contributions of internet-savvy citizens help document the geospatial effects of weather-related disaster events? We'll know more from the talk from Richard Ybañez today. But before we go to the talk proper, Faten will go over the code of conduct and give a very quick overview of YESS.
Thank you very much, Marion. Hello, everyone. Hello, Richard. Hello, Marion. Here, it is 10 a.m. So we see like we are covering the whole time zone from New Zealand to Tunisia to Europe. So it's lovely to see you again for the first edition of the SWMO High Weather Impact webinars. So before moving to the introduction of YESS, I would love to go quickly through the code of conduct. As you might see there, so there are a few points that we need to respect during the talk. And also we'd like to inform you that we are recording all content of the presentations and also the question and answer and message in the chat box. And also afterwards, we will publish an outcome reports that would include all those information. So, so this is what we wanted to share with you. Please type your questions in the chat box and mute yourself during the question and answer sessions. And yeah, thank you. And now I think I can go through the presentation of YESS. Thank you very much, Marion. YESS community, it's the Young Earth Systems Scientist community. It is a community of young scientists who are coming from the research of Earth system. It's tried to bring together early career scientists in a powerful network, providing a voice and try to together serve a better future to our society. As you might see in the structure, we have like the different working groups of YESS. We have the membership working group, we have the science working group, we have the online working group, and we have the outreach working group. This webinar series is part of the online working group. And if you are an active member or a YESS member, you can always ask to join the council and then you can be part of any of the online groups there. YESS has elections every year, so there the council will vote for the regional representative and for the executive committee. So if you have any questions, if you want to contact us, please, you have there all details. Try to write us and we will be very happy to assist you and to answer all your questions there. And thank you so much. I give the floor to Marion.
Thank you, Faten. So yes, this webinar series is a partnership between YESS and the High Weather Project. So thank you so much for this opportunity to gather a range of speakers. And just to give a quick overview, High Weather is a 10-year international research project of the WMO World Weather Research Program. And this project looks at high impact weather events, and we are very fortunate to be able to deliver this webinar with the YESS community, looking at specifically citizen science and its role in monitoring and forecasting high impact weather events. So I will stop sharing screen now so that I'll give the chance for Richard to share his screen. And hopefully that goes, and give a quick introduction for Richard. So thank you, Richard, for taking this time with us today. So Richard Ybañez is a PhD candidate in the University of the Philippines, Diliman, with a focus on natural hazard processes and interactions. His research on recent disasters caused by natural hazards in collaboration with the UP Resilience Institute involves the use of technology-based solutions such as remote sensing, rapid assessment, and drone surveys in the aftermath of disasters, and computer-generated hazards modeling. He handles geohazards and computer method courses for geology undergraduates in the University of the Philippines. So thanks so much, Richard, for taking this time with us. And we're very excited to hear your talk. So I'll give you the floor for your
So thank you, Marian, for that introduction. Thank you, Faten, as well, for inviting me to give this talk. So I'm very pleased to be able to share a small part of what we do in our research work. So this talk is entitled Crowdsourced Hazard Maps, and we specifically asked for data input from irregular citizens, from what we call netizens, for collecting data for some of the past disasters caused by natural hazards here in the Philippines. There. So before actually talking about these events, I'd like to talk a little about what we do. So our research group, specifically the Volcano Tectonics Laboratory, along with Nationwide Operational Assessment of Hazards and the UP Resilience Institute, we deal with natural hazards and disasters. We have different researchers looking at different aspects of disasters, but our group specifically looks at the surface and earth processes that allow these hazards to occur. And of course, in studying these hazards, it helps us prevent future disasters. So we are often involved in research and response of disasters as they just occurred. We have often been deployed in recent post-disaster environments to do scientific research, as well as to advise local government units and first responders. As we know, major hazards or major disasters that are caused by hazards do not necessarily end immediately, and there are a lot of hazards that can still occur after the big event. And these are the things that we want to prevent as we go into the field. And of course, the data that we collect is also used for modeling and mapping, such that we can create better data, generate better science to prevent future disasters. And I guess it's important to discuss what exactly or how exactly we collect this kind of data in the field. So this may include physical and visual observation of hazard deposits, hazard occurrences, what processes allowed the disaster to occur. We often use geophysical surveys. We deploy drones in the field. And where possible, we also conduct aerial surveys. And all of this is supplemented by remote sensing. But as we are soon to find out, sometimes with all of these tools and with all of these data generating platforms, it is really helpful to be able to reach out to regular citizens and have them also hand in data that we can use. This research field, I guess, and this methodology is particularly useful or particularly relevant in the Philippines because we are extremely disaster prone. We have several natural hazards which threaten the archipelago regularly based on this natural hazard profile from the UN Office for the Coordination of Humanitarian Affairs. We have several typhoons that are regularly passing through the country. We actually have a tropical depression that is right now just crossing the country, so it's been a very wet few days. We experience a high seismicity. We experience a lot of earthquakes due to our tectonic setting and also a lot of volcanic activity. And in the midst of all this, we also get a lot of landslides. And with all of these hazards that are, and hazard processes that regularly occur everywhere in the country, there are many cities and towns that are exposed regularly to these extreme hazards. And so when some of these big events, some of these big hazards disturb our built community, then we tend to get a lot of disasters. And specifically, many of these are weather related, whether they are directly caused by the weather, such as rainfall, tropical cyclones, or storm surges, or triggered by the weather, which is the case of for many of our large landslides, which were caused by extreme rainfall and sometimes also earthquakes. So when we have a high frequency of these extreme weather events, we have numerous triggered hazards, and we have large exposed communities, so we really get a lot of disasters. And specifically for this talk, I'd like to focus in on two examples, which is the Typhoon Ketsana or Ondoy flooding of 2009, and the recent 2020 Taal eruption, wherein we were able to use crowdsourced data. To further emphasize the value of the crowdsourced data that we receive, it's also good to look at the state of monitoring hazards in the Philippines. Our advanced and automated monitoring systems were only put in place. Many sensors were deployed only around the year 2012. So earlier in 2009, when Typhoon Ketsana flooded the capital, there were very few sensors in place. And in general, when we have large events, only then is a very large budget and funding and infrastructure put in place to prevent future events. Previously, we would rely heavily on manual observation by government personnel who were manning the few weather observation stations scattered throughout the country. For those who don't know, the Philippines has an extremely high user base for the internet. So a lot of our citizens are constantly online, access the internet through different devices. And it is this large user of internet that we relied on in collecting our data for these two events. So our first event is the 2009 Typhoon Ketsana event, or locally known as Ondoy. This happened in the 23rd of September, 2009. There were approximately 237 million US dollars in damages, particularly since this storm hit a very densely populated area. There were 671 dead, and 5 million people were affected or were displaced because of this event. In Metro Manila, we saw one of the worst, actually the worst flooding in recent memory. And it was a really shock for the local population. And so many turned to the internet to first make pleas for help, to inform other people, inform first responders, inform anyone really that they needed help. There was extreme flooding up to the third floor of houses in some of the densest population areas along the east of the capital. And besides the online calls for help, our research group saw this as an opportunity to also try and collect data, because this is one event which really took everyone by surprise. And again, with a lack of sensors, automated sensors in place, it was really crucial to collect the data and find out where the flood occurred, why it occurred there, how high was it in certain areas, such that we can prevent future events or future similar occurrences of those flooding. And so we put out a Google map wherein people would navigate to their own area. They would put a pin and indicate how high the flood was there. So our example is here in the figure to the left. So in each pin, ideally, the citizens, the responders would put their address, their street, and how high the flood was at its highest point. And you can see here in the figure to the right that we were actually able to collect plenty of data, since this was a heavily populated area. This is the capital. And we had a lot of data to work with after. At the time, there was still no Facebook, or rather, Facebook was still starting. So its dissemination was through whoever was already on Facebook. There was still Friendster at the time. And actually, it also spread around by word of mouth or through text messaging and in select media interviews. And speaking of the media, we actually were able to get pretty good media mileage for this effort. And this also contributed to the populating of our data. So as you can see in this broadsheet, we were able to publish the data, publish the links, so that more people can contribute to this flood map. And after this crowdsourcing effort, we actually also moved to flood modeling. So we were able to use this data. This spurred the research for flood modeling in our institute, also in the country, to be able to use that data, the rainfall data that we collected from Ondoy, to be able to generate maps not just for Metro Manila, but also for major cities around the Philippines. And so this website was born, and really our goal with the website was to sort of give back to the public. If we were able to publish flood hazard maps online, which would be accessible, then this would help empower and inform the public of the flood hazards in their area and maybe prevent future events of what happened in Ondoy. And of course, the crowdsourced data was able to contribute to this effort by serving as our validation model. So the rainfall data from Ondoy is actually still used up to now. That's how, that's sort of our benchmark or peg for extreme rainfall events. And so it was important to validate our flood models with the rainfall data that was observed during that day. So we would overlay the results of our computer models, shown here in red, orange, and yellow, as the 3 different flood hazard levels. And we can see that the pins are placed from the crowdsourced data. And we can see so far a pretty good correlation, particularly for this area. And so we were able to use this data to refine the earliest models that we were generating for flood. And this helped refine projects to come. So another product of this line of research was the Department of Science and Technology funded Project NOAA, which not only incorporated meteorological and flood hazards, but also sought to bring together different common hazards such as landslides and storm surges onto one platform to serve as information platform for the public, such that they wouldn't need to wait for media to tell them the weather forecast or to wait for advisories from the local government units. They would have the information on possible hazards and avoid possible disasters within their area using just this website and mobile app. And in our second event, in the 2020 Taal eruption, this occurred just earlier this year, right before COVID really blew up, in the 12th of January. It left 39 dead, those who did not evacuate the immediate surroundings of the volcano. And most of the damage was in agricultural and livestock. About 96,000 people, several families located around the volcano island, were also evacuated. So we have here in the upper left a map of Taal Volcano Island. Here in the middle, this is Taal Caldera as a whole. The northwest is the popular tourist destination Tagaytay. And so in January, Taal Volcano, which has been relatively dormant since 1977, suddenly erupted with a phreatomagmatic eruption at around 2:30 p.m. in the afternoon. This resulted in a large ash plume emanating from the crater, and of course, it generated heavy ash clouds over the immediate area. Communities within 14 kilometers, so generally about this big, was evacuated from the area. And Taal Volcano is actually designated as a decade volcano. It is designated as one of the few volcanoes in the world which, if it erupts, or when it erupts, it will really cause a lot of damage. It will cause a major disaster. It has the potential to kill a lot of people and to cause a lot of economic damage. So this bottom right is a drone shot of the volcano island. So this green island here, before the eruption, this is what it looked like 2 weeks after the eruption. And as expected, one of the major fallouts, literally, of the volcanic eruption was ashfall. There was heavy ashfall throughout the afternoon to evening after the eruption, especially in the immediate vicinity of the volcano island. There was also heavy rainfall towards the late afternoon, which sped up the deposit of ash in the surrounding area. The ash that reached higher altitudes were carried several hundred kilometers further north. So actually the heavy ashfall was not restricted to just the immediate surroundings of the volcano island, but reached several tens, dozens of kilometers further north towards the capital of Metro Manila. And so we started looking at, well, as soon as we figured that the ashfall was starting to stretch out much further than what was initially thought to be just the surrounding of the Taal Volcano, we started putting out makeshift measurements just to see if the ashfall would reach our area. So we brought out clean sheets of paper. This one to the left is me, and taken around 7 p.m. or 4 hours after the eruption. We live 75 kilometers north of the Taal Volcano Island. This picture on the right is my brother-in-law. This was taken 9:20 p.m. or 6 hours after the eruption, and he lives 120 kilometers north of Taal. And so from here, we got the idea that it might be good to start crowdsourcing our incidences or our reports of ashfall. And so to maximize the amount of data that we can possibly get, we actually went 3 different ways. We put up a Google Maps. So similar to what we first did with Typhoon Ketsana-induced, we set up a form, or rather a page on Google Maps wherein people can directly put their data or their reports. And of course, we wanted to make this form accessible not just for those who knew how to use Google Maps, but we wanted the opportunity to be present even for those who did not really understand how to plot data on maps. So we also put up Google Forms. And then through Facebook and Twitter, we put out the hashtag. This is a play on the words of Taal. So this translates to report or measure Taal ash. And besides these, our researchers actively looked for these posts, not waiting for the reports to come to us through the 2 Google platforms, but we also actively sought out reports to further augment the data. And this time, as opposed to the first time that we crowdsourced data, we had help, or some groups assisted us in putting out infographics to make it more, to make the crowdsourcing initiative more attractive, to help people understand how and why we needed the data. We opted to use the local language instead of English to make the crowdsourcing or the reporting more accessible to all sectors of society. This post on the right is myself. So I also posted a guide for using the Google Maps, again in the local language, such that it can help other netizens who are not as used to using Google Maps report their own ashfall. And of course, we also gave the option that if they did not have time to do this, or if they were finding it difficult, then they can simply post. And in the comments of this post, there are actually people who just submit through there. So what's nice here is that there were really a lot of platforms through which people can submit their data. And this is an example of, or these are some examples of what came in the reports. So we asked them to bring out their rulers, or actually anything that was of known measurement, such as this ball pen, so that we can estimate the thickness of the ash that was depositing in their areas. The resulting map looked like this. So this is only partially filtered or partially processed, but here we have the Taal Volcano Island to the south, and we can see that many reports were made northwards towards the capital of Metro Manila. And here we can see a shift of the red pins, which indicated heavy ashfall, transition to the yellow pins, which indicated much lighter ashfall. And in each of these pins, unlike before, that the flood pins just indicated height, people were now able to include a picture of their reports. This photo is cut, but it shows a car which is lightly draped in ashfall. So most of these pins, there are also accompanying pictures. And this data is really helpful, especially in expanding the study area for the ashfall. As you can imagine, the study area stretches several kilometers, and due to the nature of the ashfall, people would end up cleaning the roofs, the roads. So this data disappears very quickly. We actually had to move very fast to put out the forms and the maps, so that before people ended up cleaning their immediate areas, we were able to collect the data. And this crowdsourced data is supplementary to the field gathered data, which we did. So we entered the 14-kilometer danger zone when Taal was still more or less erupting, and we were able to collect ashfall data ourselves. So here in these two pictures from the Earth Resources Laboratory of UP, we can see images of what the ashfall looked like up close in the first 7 or 10 kilometers from the volcanic eruption. We have drone imagery here collected by our research laboratory here and here, which would be put together as orthomosaics. So we were actually able to collect a lot of data on the ashfall, both from our usual platforms, as well as from the crowdsourced data. We actually were not yet able to expand the research on this up to now because of COVID. We have not been able to sit down again and really go through the data and synthesize it, but we have done some preliminary work on how to put all of this data together. And so far what we are seeing is that the crowdsourced data, the reports, agree with the ashfall models and the meteorological models which were developed, showing the ash clouds moving northwards. So here we have Taal Volcano Island, and at the time, the higher elevation, higher altitude winds were moving northwards. And so this explains or this corroborates our north trending ashfall reports moving towards the capital of Manila and the provinces actually further north of that. We have high resolution images from remote sensing platforms, which are only accessible or available for the immediate surrounding of the Taal Volcano Island. And of course, for those who are familiar with remote sensing, there is a limitation with cloud cover. And so here in this map, we can see the gray areas, which indicate ashfall. And these are the only data sets that could have been observed through remote sensing platforms because of the limitations. And so we find that the crowdsourced data is really helpful. It can be used to add on to all of these data which we have already, which are already existing. So given these two events of crowdsourcing that we've done, there's some lessons that could be learned. First is the comparison of our first practice, first event of crowdsourcing, and the second one. In the first, we had to rely heavily on paper and news media to let people know that we were collecting data. So not a lot of people were on the internet yet as much as now. Devices, smartphones didn't really exist yet at the time. And so people had to go onto their computers to actually plot data. And of course, not everyone has access to these desktops and laptops, especially in the immediate aftermath of a disaster. We did not request for images at the time, again, since image capturing devices like smartphones did not yet exist. Only a handful of phones at the time also were able to immediately take pictures. And we only relied on one platform, which was Google Maps. But now we were able, for this more recent event, we were able to leverage the reach of social media. Hashtags in particular were very powerful. And of course, you're able to appeal to people's creativity with infographics and a play on words in hashtags. Everyone now, or mostly everyone, has devices which can take images and upload. A computer and a laptop is now no longer necessary. And definitely it is now more accessible by all sectors of society. Some pros and cons, however. Of course, the pros, there is a wide reach and scope for using crowdsourced data. Definitely the geospatial range of the data that we were able to collect far exceeds what we are able to collect. Remote sensing can try and make up for this, but of course, it's good to be able to somehow validate this data on the ground. We were able to get lots of data input and collection, again, at a far greater scale than we could have done ourselves. And it is really, I guess there's a sense of fulfillment, and it educates and empowers our citizens when they know that they are contributing to the collection of data, to the generation of science, and the prevention of possible future disasters. With such a large data set, the data set can correct itself, even if some people have erroneous input. They put knee-high floods, but it was really chest-high. Their neighbors and other people around them are able to correct that data. And again, it is able to supplement our own data and observation platforms. Some cons, however, there is of course a need for verification. In the flood reporting module or map that we set up, so some people would put pins in the middle of the ocean or the sea and say that here it is still flooded. So of course, we have to look out for some of those people who just want to make fun with the data. Sometimes the data is incomplete, incorrect, or may need interpretation. So this is the case for measuring flood heights or for measuring the thickness of ash. So at least the picture was able to somehow make up for this. It allows us or the research team, the scientists, to interpret the data itself without relying completely on what our citizen wrote on the report. And again, we have to watch out for malicious entries. And I think this was discussed in one of the earlier talks or earlier papers, and that it is very difficult to use crowdsourced data as a primary data set. So in most research works, you really have to also use more objective observation platform to build up our data and our analysis. But of course, crowdsourced data would still provide a very great supplement to this data. And that's about it. Thank you for listening.
Thank you, Richard. That was a really fascinating talk, and especially for me because I was actually in the Philippines for two of these events. So it's quite good to see the crowdsourcing initiatives that happened then. And I guess from what I saw from this talk, it's that citizen science or crowdsourced data can actually go through different types of hazards from flooding to ashfall. And we can see that there are benefits in doing crowdsourcing. And yes, so really thank you for your talk. So I'll give people a chance to put in their questions, but we do have a few questions in. So thanks everyone for putting in those questions, and we will go through them. But I'll probably start with a comment from GN, and she or he says, hello, good afternoon. And question is, during Ondoy, I said, did people still use Friendster? And I guess I'll add a little bit of this question is, how did you decide which kind of social media tools or platforms you will use for this crowdsourcing, initiative?
I do believe Friendster was still up at the time, unless my memory fails me. But of course, the answer would be that to have the initiative, the link on all platforms as much as possible. So social media really wasn't a thing yet then. It would grow in the next year or two. So we actually really relied on traditional media at the time.
Yeah, I think I recall, I think Facebook was still quite young then. So yeah, it's good to know that look at traditional media, but also social media and doing this crowdsourcing. Yeah, so I'll go to the next question from Martha. So she asks, how do you think it can be encouraged for people to participate more and contribute in these, crowdsourcing data gathering?
I think it would be really useful if you explain to them why the data is being collected. And I think for the ashfall, in one of the longer posts, we would actually discuss that this helps validate computer models. Of course, we have computer models for more rare events. I mean, for flooding, it's very common, especially here in the Philippines. So our flood models are very easy to generate and to verify. But for more rare events like this ashfall, it's actually very difficult to get actual data. And if we explain to them that this helps forward the science, this helps generate knowledge, and this helps us scientists and engineers create tools to monitor and to prevent future events, then people are very happy and eager to contribute their own data. And especially here in the Philippines, I guess it helps that people feel like they're part of something bigger, something that's not very common and not something you find every day, and that helps them motivate them, give data.
Yeah, I saw that in your talk you said that the Filipinos are very internet savvy, one of the highest internet usage. So I think that helps. But I also want to commend one of the things that you said in your talk, because you showed that you provided instructions for people to actually contribute data. And I think that's a really good initiative to actually not assume that everyone has that capability and provide some way for people to engage. So I think that was really cool. Yeah, so we have a few questions in the Q&A and chat box, so we'll go through some of them. So we have a question from Bernard. His question is, since one of the data gathering methods depends on public reports, i.e. anyone can report, do you have experience with receiving troll reports, unusable data? What is the ratio between good and bad data, and how do you deal with this?
Like I mentioned in the first crowdsourcing initiative that we had with the flood, a lot of people would put pins in the middle of a lake, of the Manila Bay, of the ocean, and say that there is still water here. So actually, some developers would come in later on and help refine the map and refine the data set such that bad reports would be canceled out by more accurate reports that would interpolate in between these erroneous or rather troll or malicious reports. There was actually not a lot of bad reports really. It's just really a handful of people who were, I guess, bored at the time and wanted to have fun. But in general, the integrity of the entire data set is pretty good.
Oh, cool. Yeah, I think that's one of the things that we can see, that people are wanting to contribute good data. I think what we can see is that people try their best to provide, and I guess we can't avoid getting some less malicious, but then I guess in terms of ratio, most of them are good. That's good to know. So we have a follow-up question from Bernard. So for hashtag reports, how do you gather these posts? Do you have a methodology, or do you automatically harvest, clean, and process the data?
So our team, we actually wanted to get a computer scientist or a programmer on our team during this time, but of course everything was rushed. So what we did have was a lot of manpower in the form of our undergraduate researchers. And so we opted to just do it manually. So I think, again, if there was a more automated way to do it at the time, that would have been better. But again, in a post-disaster setting, you really can't really be efficient about everything. So we just have to get the work done.
That's interesting. Yeah. So I guess finding a way to make the most out of what you have, and I guess in this case would be manual, but I'm sure there are like different initiatives to kind of automate some of these things, and I'm sure there's lots of work in that. So just a follow-up, because I'm seeing that there are some related comments and questions. So coming from that, so Brian asked, he commends you for making a very strong case for crowd observing. But since we talk a little bit about analysis, is there a way for participants to contribute in the analysis in some way? And do you see this as something that you or your team will be doing?
I think in our field, in geology, we're not really experts on having people actually also contribute actively to the analysis process. I've seen our partners in geography do this better, but it would be good to actually bring out the map that we generate and have citizens or those who contributed to it check again. This is definitely a good idea, and it's something on the table, but we're not really used to it, but we want to learn.
Yeah, definitely. So I guess this is a potential for collaborations, interdisciplinary studies, and definitely we can learn from different disciplines. But it's good to see, citizen science and crowdsourcing to show the case that citizens can contribute meaningful data, and eventually maybe also with the analysis. We have a question from Mohan. Is there any emergency warning through mobile SMS or community volunteers in the Philippines? And how does that relate? Yeah,
in the aftermath of the 2009 event, so DRR as a practice, as a law, as everything in the Philippines was really overhauled. And so in the aftermath of that event, our civil defense agency actually reorganized and put out a lot of new policies, infrastructure, And yes, so that includes now emergency warnings through SMS. So at the time in 2009, no, there was no automated warning system yet through SMS. But nowadays, yes, we do receive it. Community volunteers, generally out in these post-disaster settings, there's organized and then there's unorganized community volunteers that people just want to help in any way. If there's an organized way that is accessible to them that they can help, they will. And in other cases, people just go out there and help.
Yeah, that's good. Thanks for answering that question. So we have another question from Martha. She's asking, was crowdsourcing also used to locate fissures on the Taal Volcano eruption or in any major earthquakes?
So we haven't deployed crowdsourcing yet in other events. So there was a major earthquake in the south of the Philippines earlier, late last year, and we find that it's actually hard to have people who just experienced an extreme earthquake contribute to crowdsourced data because the effects are usually pretty bad. But as for the fissures, yes, we actually did put out another Google Maps platform and another Google Forms for the fissures. I just didn't show it anymore since the data was scarce. So most of the fissures that were reported in the days after the initial eruption were actually found in the permanent danger zone. So by the time these fissures started showing up, majority of them, well, the people were no longer there to report them. But actually part of that field work that we did, field investigation with the drones, we were actually looking for the fissures more than at the ash.
Let's see, yeah, quite interesting. Yeah, so we have a few people thanking you for your great presentation. So I think people really appreciate this great presentation that you have given. One anonymous attendee is asking, how do you clean the data that you've gathered? What's the process for cleaning crowdsourced data? Because it's a huge data set, isn't it?
Yeah. So for us, when it's just us geologists involved, we do it manually so far. But again, with the 2009 data set, so we were able to bring some programmers on board and they helped clean the data for us. So I'm not really privy to the exact terminologies and methodologies that they used, but they were able to eliminate some of the more erroneous data for us.
Cool, thank you. Oh, so we have a question from Dazzle, and also she's thanking you for a very interesting presentation. Is there a process already to validate if indeed crowdsourcing reports were true? How important is having an institution to manage and make sense of data?
So, like I said, we had some programmers come in and fix it, and I wish those same programmers would have been around for Taal. Maybe the job would have been easier and faster. But yeah, we leave the processing to them to eliminate. So I assume there's some sort of statistical checks that go on there to make sure that only the really erroneous data are removed. And we find that it's important to have to validate this data and to analyze it to make sure that the data doesn't go to waste and it really goes forward in improving the science, improving our maps, improving our models. So of course, if we ingest bad data, then our models and maps will also turn out bad. And in this line of work, bad models and bad maps can actually get people killed. So it's really, really important to validate this data, especially if it's going to go into the final models and maps that we put out.
Yes, so I guess there's a sense of responsibility as well with managing this data. Yeah. So, Fatin, do you want to read the next question?
Yeah, thank you so much. Yeah, first, thank you very much for the brilliant and the impressive talk you gave, Richard. It was very interesting for me to know and to hear about it. I know it's very challenging to work with the community and crowd resourcing. And maybe this is also the topic of the next question. So Yisan here is asking, would crowdsourcing be limited on the strength of the internet connection present in the area? So would it be less effective on a remote area where internet connection is not too good? Yeah, this is a very good question. So please take it.
So, first of all, we expect disasters to occur, of course, in more populated areas by definition of a disaster. And in more populated areas, we expect internet signal to be much better. So, yes, this is a particular limitation for crowdsourcing data, especially if it is through this method. So, we have to take this into consideration that, of course, especially in our maps, not all areas will be covered, especially since we're just disseminating through social media. There are really patches wherein people won't be able to contribute, whether there is no internet or they were not able to see the call for data. So there are actually many other various factors which would lead to what we say blind spots in the data in the map. So there are other ways to get around this. Of course, you can deploy people to the field, hopefully much later after the post-disaster setting, to interview people by pen and paper, face-to-face method, so that we can get a better grasp of the data. But of course, in the immediate aftermath of the event, internet and online is a much faster method to collect data, even if it's not, if it doesn't cover all of the areas that we would like at the moment.
Thank you very much, Richard. So there is another question coming from Jan. He's asking, do you consider participatory 3D mapping for this?
We have not yet conducted participatory 3D mapping, or actually any kind of participatory mapping. So it's something that we'd like to get into, and not just involve people or citizens at the first stage of data collection. But again, there are appropriate methods and appropriate times for this. So we keep it on the table. If ever we are able to apply participatory mapping, then that would be good for us and for the contributors.
Yes, I guess there's a different range of citizen science projects, and I guess participatory mapping would involve a lot more, I guess, contribution and participation from the communities. But I think this is a good opportunity as well. So I guess from Jeremy, we have a question. Are there any efforts from the local government units to train or at least familiarize their constituents on the identification or even terminologies of these hazards? I think that's a great question. How do we connect with citizens who are not very familiar with terms? And
So I think there's been a lot of effort in the last decade, especially in the last 5 years, to empower local governments who in turn empower their constituents. So we, the UP Resilience Institute, Project NOAA, and the other government agencies have been doing a lot in the last few years to give materials, to make materials available online in hard copy, printed, in different languages. So there are a lot of local languages in the Philippines, and there's been a great effort to translate it into all the major languages. And yes, there's been a lot of work going into that. And I think it's actually saved a lot of lives in the last few years.
that is good to know. Fatin, do you want to take the next question?
Yes, please. Thank you. So the next question is coming from one of the attendees, and he's saying, thank you for the wonderful talk. Is it possible for government agency to use the crowdsourcing to improve the affected area?
I hope, I hope so, but I can't speak for government agencies. Of course, as a research, we are a government research institute. We're a government university. And of course, we are very open to any kind of method that can be used properly, that can help build the data. I think government agencies um, generally have a lot of on their plate at all times, so they may not be as available in exploring these other methodologies. What I do know they do is talk to local governments and talk to areas, to specific communities that have been affected by landslides, by flooding. But crowdsourcing, especially on an online and at a large scale, I'm not sure there are any efforts yet for this.
Thanks for that answer. So final question, and just in time, and we have it from Faye, and she says, thank you, great talk. And this is, I guess, related to the question earlier. Does the population density of an area influence how many observations are reported? And does it matter, true absence of impact versus impact with no report? If so, how would you be able to adjust for this?
Of course, yeah, this is related to the first question that when we put, there are a lot of factors that would prevent data from being collected in a certain area. Of course, if the people there saw it, if they want to contribute data, if they have the internet connectivity and so on. And so what we take from this map is that the lack of a report in a certain area doesn't mean that there's no event. It just means that there aren't people there to report. So actually one of the categories that we asked for in the map is not just for people to report how high the ash was or how much ashfall fell in the area. We wanted people to report if there was no ashfall in the area. So it was important for us that people also chime in and tell us that ashfall didn't occur in their area to help improve the data. But again, of course, this is one of the reasons why we can't rely entirely on crowdsourced data, since there are a lot of uncontrollable factors that come in. That's why it will always be supplementary to other data collection methods. And it can especially go hand in hand with remote sensing as a method. Since in remote sensing, you cover a very large area, but of course, you're only able to measure what you see from above. And remote sensing with a very large scope, along with crowdsourced data, which shows us actual data on the ground, these two hand in hand can actually generate an excellent data set, and they cover each other's strengths and weaknesses.
Yeah, I think that's really cool. Looking at the complementary of data sources, how to make that different data sources to make rich insights to, I guess, what's happened after disasters. And thank you so much for everyone who raised a question, really interesting questions. Thank you for your engagement. And thank you, Richard, for answering all these questions. So for me, really, just want to thank you for your talk. And I truly appreciate how we can use crowdsourced data. And I can see that, we could use it to help prevent future disasters, help people prepare by giving access to that data, such as the flood maps from Ondoy, but also how this is used by scientists as a baseline for future research. So I can see really good use of crowdsourced data. So thank you for giving this really interesting talk, and thank you to our audience for all the great questions.
Yeah, thanks for inviting me to give the talk.
Thank you very much. So I really enjoyed hosting the third webinar, and it was very, very impressive talk. So thank you very much, Richard. Thank you for your time. Thank you also for the nice presentation. And also thank you to all the attendees for the super interactive session. Thank you for being there. Details about the next webinars will be posted on our website. So I shared the link of the website and the session of the webinars on our website, so we can find there all details. I hope to see you next time in very few weeks. So thank you again. Have a great day, have a great afternoon, have a great evening, and I look forward to see you all next time. So thank you so much.
Thank you. Bye, everyone.
Bye-bye.